this transcode working? I think it might be. Looks like YouTube's getting video. And let's see what Twitch is saying. The Twitch client is having trouble refreshing, but it looks like it might be running too. Alright, yeah, looks like Twitch is working too. Alright, welcome back if anybody's watching. It's pretty late here. It's a little past 2 in the morning, but let's see. I was working on the video transcoding setup, and I felt like it was worth a test, and thought I could get a little bit more work done. Give the video something to chew on and make some more progress on this project. So yeah, let me briefly, turn on the camera so that you don't have just blue screen to deal with. Oh man, I feel like this whole thing makes everything more vaporwave. Yeah, so I've already got a few of these computery objects down here. There's one that's like a general purpose workstation that I also use for recording, and then there's one that I pretty much like full-time use for streaming. And then the thing that I just had to add was this little tower back there is a fairly mediocre Linux machine that happens to have an okay NVIDIA GPU on it, and so that's now the intermediary between the actual video processing machine down there that's doing the streaming and the Twitch and YouTube. So that one's taking in a video stream at like so I have this encoding machine up here. Whoa, that's some bright light there. Yeah, so that encoding machine up there is that's currently encoding H.264 in hardware on the GPU at 12 megabits, which is a nice high rate that I can use for editing later if I want to. And it's also nice for like transcoding down to other bit rates. So Google with YouTube just transcodes absolutely everything, so I can just throw them whatever bit rate I want. So now that I just got the fiber internet installed here, I can just throw that entire 12 megabit stream at YouTube, and it seems like it's complaining a little bit. YouTube's giving me a warning about the keyframe settings, but maybe it's fine with the bitrate. Yeah, anyway, so I might have some encoder settings to work on still. But the current setup is attempting to just throw that huge stream at YouTube and then transcode locally to Twitch's maximum bitrate, which is 3500. And that stream seems to be fairly nice. I was like streaming it over Wi-Fi and watching it on my phone. It seemed to work pretty well. All right, what we got here? So YouTube's complaining. Twitch seems fine. Oh yes, Twitch is happy with the transcoded stream. I think YouTube just doesn't like my keyframes, so that might just be a matter of tweaking my the hardware encode settings on that on the main broadcasting box. So I don't think I can do that while the stream is running. So well, I think I can actually do like a really momentary restart on here without anything actually disconnecting. So maybe I can actually fix that. Use this as a debugging opportunity. Let's switch back to the camera. I don't have to hold. Hi Tuco. Yeah, I don't see the options in OBS to change this easily, so I'm going to have to dig around later and potentially run some experiments. But at least now I know that's a problem, so I can try to research it. I don't know actually what the implication is for YouTube. I don't know. It seems to be having trouble buffering the stream on this end, so... Yeah, alright. It's hard for me to tell whether the stream is coming through smoothly for everyone out there, but my laptop, which is trying to view the stream on the YouTube dashboard, keeps going back to buffering it, and the tool is complaining at me. So, yeah, it might actually be best to just kind of take that hint and try to fix the keyframe settings. And all right, video encoding is so much work, but anyway, I guess while I'm here, I can talk a little bit about the next thing I was planning on doing for this actual experiment. So, I mean, there are a lot of ways to bring this. On the last stream, I was focusing on, well, I mean, it looked like I was focusing on trying to eliminate this this noise I was seeing on screen. And I mean, there's a lot of ways I could have gotten rid of that if I just wanted it off the measurement. But actually, my ultimate goal was to try to make the hardware glitches that I'm introducing more reproducible. So to that end, if there are any power waveforms that aren't correlated with something I expect to be there, then it's noise or it's something else that's contributing to non-determinism in the system, and I want to try to get rid of it. So that's what I was tracking down. And there was this waveform that I thought was, well, I'd been assuming that it was related to one of the clocks in the system. There's a clock that's designed to replace the crystal oscillator that usually feeds the Ethernet controller, and it's kind of a slowed down, divided version of the main system clock that eventually ends up getting multiplied back to that frequency and running the microcontroller core. So it looked like it was close to that, but when I was actually able to measure it, it wasn't. And then I started changing the circuit in other ways. Like, I think what actually triggered it to start behaving differently was when I modified this setup so that instead of just probing it with the high impedance oscilloscope probes, I modified both the chip whisperer and the oscilloscope setup to probe with a consistent 50 ohm-ish impedance. And so that should give me nicer signals in theory, or at least about as good as my the passive probes are. But I think that also ended up changing the impedance of the voltage regulator circuit enough that the oscillation pattern changed. And instead of a consistent pattern, or instead of a consistent tone, I was getting like a modulated bursts of a tone as it went into oscillation and then damped itself and then went into oscillation again. So that was kind of a weird signal, and it improved a lot by adding some more capacitance very close to the processor. In addition to the capacitance that's, like 3 or 4 centimeters away. So, and there are some various reasons why the capacitance farther away isn't having as good of an effect. I think a lot of it is just going to be the inductance causing effectively the current pulse to propagate relatively slowly through that that transmission line from the circuit board to the capacitor bank there. So I think that's the dominant effect. I'm a little suspicious if maybe this cable this little flat cable I coupled together is not so great, and so I might try alternate cables and just see if that changes the performance. Like I've got a reel of some random coax that's probably okay for this that I might try putting in there. So I can do some things maybe to improve the performance of the circuit that applies the capacitance when I want it, but not when I don't. Since ideally I want that capacitance gone during the actual glitching event, but I need it there to stabilize the voltage regulator otherwise. But in lieu of improving that circuit that I've already spent some time on trying to optimize, I was going to see how far I could get just by adding capacitance on the on the main circuit board. So that's capacitance that I can't turn off, so it's there interfering with my ability to provide fast glitches. I have to drain energy out of those capacitors during that initial edge of the glitch that I'm causing. So that's not so convenient, but it's a trade-off. I think a little bit of that, enough to damp out the terrible oscillations in the voltage regulator, might be worthwhile. So in the last stream, I ended up with 0.3 microfarads there, so that might be a good compromise. There's still some oscillations left, but it might be manageable at this point. I hadn't really gotten a chance to look super closely at it since making that last adjustment. So there are various ways to go next. I mean, I can try to improve that situation more. I also was noticing that the power coming into the regulator was kind of messy, and it might just be worth, I think the closest place I have is there's actually a point. Oh, actually I've already got a little shunt in there. So there's a feature on this circuit board, since it's like a development board anyway, it's designed with a current shunt that you can take out for measuring the current just going into the processor's 3.3 volt rail. So I think I've got a 1 ohm or less resistor soldered in there. But I don't think I have any capacitance on the system on a chip side of that resistor, just on the other side. So, because I think I was using that previously as a way to measure the current on the 3.3. Whereas I think now I might want to repurpose that for stabilizing the 3.3 volt rail, so I might actually want to add a bunch of various little capacitances on the system on a chip side of that, just to see if I can make that as flat as I can get it. Because that'll remove noise that is not at all correlated with what I care about, which is the CPU's execution. So that's another thing I can do. The thing that I was actually thinking about doing next, which I think maybe I won't do that tonight since it's late and the video streaming is working a little bit less well than I hoped. I think my transcoder is good, but now I've got to go change my my original encoder settings. But yeah, I think the next thing I was planning on doing actually was to get get some mixed signal analysis going, since I've got a good probe for the analog signal now going over this nice red coax. But I think the other thing that would be super helpful now is to get some. So there are two digital signals I would really love to see on this. One is I would really like to see the least significant 8 bits of the counter in that inner loop, and I think there's going to be some interesting details in implementing that, because I don't want I want as few as possible instruction cycles on the CPU to be involved with taking that counter value and putting it on the GPIOs. I want to mostly be just doing that counter increment, but I also want to make sure that a glitch can't easily just completely break that GPIO. So for example, if I was storing a base address in some register and the glitch clobbered that register, then if I don't reload that register for the entire duration of the test, then I lose that counter. So maybe there's a trade-off between the amount of information I can collect and the ratio of glitches that end up hitting my instrumentation versus the loop that I'm trying to make into my glitch target. So actually, I think the first step in implementing that, I want to look at the disassembly of what my glitch target right now, just to get a baseline for how efficient it is right now. Since, I wrote some C code that seemed like it would give good disassembly, but I haven't bothered to look at the disassembly since it wasn't a big deal. But I'm going to be caring a lot more about that soon, so I want to get a baseline idea of how well that's working so far. And then with that in mind, and with the pin assignments on this board in mind, and what I have free, and with this processor's instruction set and memory map in mind, I want to choose an I/O layout such that I can dump that counter directly onto something I can get into the logic analyzer on the scope, with as little effect on the rest of the circuit as possible. So that probably just means finding something that's like nicely aligned to the bottom of a word, and I can just like splat something out onto an I/O port with minimal interference. But that'll involve looking at the datasheet on the processor and the schematic for this board again to find the settings for that work out. So that counter is something I want. The other signal I want is I would like the processor to, I'd like this firmware to also try to detect the glitch on its own and to give me a trigger signal. So I think I can just write some code that checks to see if those counters are a value other than what they would be without a glitch, and then set a GPIO accordingly. And that's all I need. I can just use that as a hardware trigger on the oscope, and then when that tells me that the glitch was successful for that particular definition of success, and then I can use that to go back in the trace that the scope has captured and see both what was happening to the counter, including the timing of it, like, was it skipping iterations? Did it just momentarily change to something different? Did it start doing a different behavior? Did the different behavior continue? If so, for how long? Did it affect the oscillator? So I can start to answer those kinds of questions. All right, I think that's everything in this miniature stream test / brain dump. Oh, there's a little bit of chat to catch up on. I can do that while I drink my tea. I'll try not to slurp. It's always interesting to see who's awake when I do the streams in the weird times. Oh, that's cool. I'm also getting some feedback that for one data point from Austin that they're not seeing any dropped frames or buffering, so that's cool. Looks like as I'm glancing at it here, it seems to be all right. I wonder if my YouTube client was just having trouble figuring out what bandwidth to use. Anyway, I continue to learn much more than I thought I needed to know about video encoding and video broadcast and all this. This is starting to feel like a little television station over here, but it's nice that none of the equipment that I've had to get is super expensive for that. I think the most expensive parts I've got in the streaming setup are the quad-core PC that runs the streaming and the capture card that I do most of the capture on, which is like a Deck Magic with 4 SDI inputs. So, but if you're starting out and you don't need a bazillion channels, then I've been super happy with these little USB 3 HDMI capture doodads that you can get for as low as I think $150 now. And those are really nice. They tolerate lots of different formats. And they just give you a standard USB video device that works with any software. So those are nice. Before I found those, my favorite was the Elgato HD60, which doesn't give you uncompressed video because it's only dealing with USB 2 bandwidth. But it gives you lightly compressed video over USB 2 that its driver then decompresses for you, and then you have to recompress it again if you want to do anything else with it, like send it to disk. So those require a bunch of CPU overhead to kind of deal with, and there's a lot of latency involved. But I still use a couple of those to do the kind of non-streaming related recording. So like when I record the microscope, which doesn't have its own video recorder, so I can edit that later, I use that recorder still. Let's see if I can end this stream with a little bit of Tuco Cam. Oh, such a beautiful cat. It has been super interesting starting to see signals over 100 megahertz with this new scope. I don't know. It's like there's a bunch of stuff that I can I can try to understand the theory of, and I can read in books, and I can try to make a mathematical model of, or run a like a spice simulation. But I've always found that learning things is just so much faster when you can get your hands on them, and so it's an interesting opportunity to start seeing things into those frequencies and start to get more of an intuitive idea for how how the kind of more physics side of signals work, and it would be interesting to start designing things in microstrip land, for example, where resistors and capacitor, you don't really have resistors, but like capacitors and inductors, or just circuit board traces. But I think it's also really interesting in this glitching apparatus to see things at those really small time scales that that are really unintentional in these circuits, and then to try to figure out how to control those. It's been an interesting debugging exercise. Oh, it's raining out here. I think 2 goes into the rain sounds. I don't know how much that's coming through the microphone. Considering how much environmental noise it picks up, if the heater's not on, you're probably hearing it. Alright, I'm going to try to get some sleep over here. I'll see you in the next stream, folks.